All right, everyone. I hope everyone is doing really great. So today we are going to start a software which is called LS-DYNA. So one may ask like why we are starting this software. So first of all, we have to really understand the significant meaning of this software, why it is so much used into the industry. So before we answer all these questions, let me first introduce yourself about this software, about me, and how we can just simply go ahead and what are the learnings that we are going to see with respect to this software. So first of all, these videos are much more related to the simulations. So particularly when we go to the industry, we have like two departments. One of them is a designing department and one of them is a simulation department. So from the very previous, like from the history, like CAD is being known for its designing purpose and CAE is known for its engineering purposes. Now we also have to admire like how the CA can really lift up the product innovation and development cycle. So far, like almost 20 years ago, there wasn't something like that. These software they really exist, but they were not so much in use. But believe me, as how as of now in the current era, they have an equal importance in the designing as well as the simulation, because that's how you understand the design is working or not without spending a lot of money into the prototype, or not only prototype, or just making a design that is not working at all. So one might see like it doesn't work at all, but at a bigger picture, when you have to pass a lot of regulations, when you have to make your design really working in terms of the situation where you're putting up your product. So this is where this plays an important role. So one might ask like why we are just looking out for this software only. Probably in my last series, we have also talked about this Abacus, and Abacus is really good software. It is from Simulia, the Solve system. Like they all have a collaboration, and that's how that softwares work. But when we talk about Impact Blast, and certainly much more powerful software compared. I'm not here to compare any particular software, but yes, it is known in the industry. Like for Impact and Blast, this LS-DYNA is something really powerful. So just to get you introduced about this software is like from Liverpool. So it is an open source. Only like pre and post processing are the open source, and if you have to solve the some solutions, like if the solver is not is like taken up by the ANSYS, and you might be updated like right now ANSYS is being taken up by Synopsys take up the ANSYS. So that's how like the whole cycle of the software comes in. And but overall it's a really powerful software, and we should try to understand it. So what now, just even if I start, what should one understand, like how to use this software, what are the theories behind it, and one should not simply become like just not only to use the software but also to understand the the basics behind it, the physics behind it, like how all other things are correlated, so that if there is an error you are able to resolve it from your own, rather than just becoming used to with the software only, because software is just like you can learn it as quickly as possible. But if you don't know the basics, I'm sure things gonna be really hard when you dig into this domain. So as I told earlier, this software comes into the CAE domain, and CAE domain is really divided into multiple subdomains. But if you think about like impact and blood, this is what where we generally, not generally, but most of the time we try to use this software. Now, the theory is a bit complicated, and what I really want to go ahead with this video, with the help of this video, is just to let you know the software, and how exactly, some key principles behind it. So one may ask like, why am I doing if there are already lots of videos on YouTube or something like that? So actually the point is, none of them are going to explain you the actual theory behind it. So what I have done from my years of, I have like almost a decade of academic experience, and then getting into like almost 5 years of industrial experience. So my experience shows us, like tell us that if you really have to learn something, you have to understand the basics of it. And so far, whatsoever you see, you just simply see some tutorials of how to use LS-DYNA and some key things, and that's how you learn it. But make sure like this is not gonna work for your long time. It can help you for a one single project, but nowadays companies are not working for one single project. They hire you for multiple projects, correct? So I really recommend you to really go ahead with this sort of my let's say series of lectures where I will explain you about these uh, software, the theory behind it, and we will really dig into some product applications part of this. It's gonna be really interesting. So one from this lecture series gonna understand like and really appreciate about like not only to use the softwares but also some key concepts. I'm not going to make the whole big theory back into this software, but rather than I consolidate from my years of experience. I'm sure this is not what you're going to get it from any other tutor, because they will just directly dig into it. But what I will do, this is like what my pain was. I just really want to make it easy for all the viewers so that they can understand the software, they can understand the back end theory, and when any error comes into the account, they can from their own they can try to resolve rather than going to some really big experts. And just believe me, those experts are the same. The theory that I will give you, they know that theory. That's the big difference from the one who only know the software, but from the one who's an expert. So that's how we will just dig into it, and we will understand. First of all, we will try to understand a bit of the theory. Okay, so when I say theory, so everything starts like just try to understand like we have a design, and after that we have to do simulation. So simulation is very realistic. You have to make it realistic. So generally, let's say if I have a like let's say this pen. So generally the theory comes, this pen is like a continuous body for us. So that's where like continuum mechanics comes into it. And the theory of continuum mechanics is being applied to these all the software. So just believe me, if you know the theory, this is just one piece of software that you are learning, but you can apply that theory into another piece of software whatsoever you see around the world. So when I say about continuum mechanics, as you can understand, okay, continuum means something continuous, and we have mechanics. So somehow when you say about mechanics, then all are like, then there's a light up in our back of the mind that, okay, so mechanics means something physics and mathematics. Yes, that's true. Like, these two are going to play a major role into it because that makes the basics, and that's how you go ahead into this software. And so physics, math, then applied mechanics, all this mechanics part, and then we just enter into this solid mechanics part. We have already learned, we have already seen more about it, and then comes the continuum mechanics, and then comes the softwares, okay, and particular domains or subdomain of it. So that's how, if you link all together, that's how you make or you become a really uh, into the softwares and to resolve the problems at your own pace. All right, so as I told, like, it has a continuum mechanics theory behind into it, and somehow my lecture series is gonna be like initially just getting dig into the software, then explaining the theory, then getting into the product, and then trying to give a lot of tips and tricks. So it's not only going to be okay, you first have to learn all this theory. No, first let's step by step, like, okay, what is the software? Okay, once we understand software, then I will just try to let some theories out of it, then some product applications, some of the analysis. So it's not gonna be like a very big nightmare for any new user who want to learn this software or learn the theory. So that's how a combined combination. I'm sure this is not what you are going to get it from anywhere else. So just believe on me, and let's dig into the initial phase of the software. So just if you can see, the software is like some people say it's very complicated as a user interface, but believe me, like if you spend like 1 week, it's gonna be very much easier for utilization of this software. So when I see, like, as always, like we have this file, so this is everywhere common, and we have some of the options here, miscellaneous, where we can do some post processing. Then we have some views. For example, let's say my view is like faded right now, I can make it plain, and so I can just play around with here and just make it graphic. It's all up to you, like how you want to work on. Generally I used to make the plain view, and you can just work around like geometrical shapes, like when we design something, how it looks like, we will see right now, right after it. Then element shade, like how we will see everything. But here you can see everything comes here, something like report, then post processing part of it, like, yeah, this is what we here it shows about geometry. Okay, geometry, FEM, and application, the all three options you're gonna see it here in a bit much more complicated way, rather than I can say much more easier way, because this is where you will be using it at each and every day for your purpose. But this is much more consolidated way of referring the same thing. And you may say, ask Karan, how? Okay, let's see. But the first one is geometry, then we have a reference geometry, correct? This is the reference axis. Let's go into it. So we see, okay, we have a mesh, then at the top of it, what we see is a reference geometry. When I click, what I see is axis, correct? So you can see it opens up all the options that we see here. If you can see, correct? Now just try to compare, we see everything same. So just believe on me that these are like consolidated options, and everything in detail you can find it here, which are mostly being used during the work on this software. Then we have FEM part of it. So we have geometry. It's just like, this software can also support some designing part of it. So initial designing can also be, or some modification, very small modifications can be tweaked here. So yes, it can help upgrade itself. Then for sure it is meant for like FEM. Then we have a lot of applications of part of it. This is a multi-physics software. I don't really want to make you a big nightmare, but this is what we will see later, like how we should really appreciate the software, like not only like we can do impact in class, but many other noise vibrations and all, so many simulations out of it. So it's a very powerful software. The only thing is, since this is LS Repos is open source, and I mean, since it is an open source, so you might not see like any other software very easy interface. It's a bit not difficult, but with tricky, and this comes with an experience. But it's gonna be worthy when you just really get into it. That's why it's an open source software. You spend some time into it, and yeah, so this is all about your some settings, configuration settings. That's it. And the same you're gonna see it here on the right side. Every stuff is there. Now I just don't want to make it much more deep into it, so what we can do, we just quickly see one of the let's say a design. So let's say I just want to make a mesh. So don't think you are learning right now, just see what I'm doing right now. Okay, so I go to the shape mesh, and let's say I want a box solid, so it's all okay to me. Let everything be default. Okay, and I just simply create, accept, done. Okay, so all right, so the first step is already done. You created a box, as you can see, like it has some mesh. So what I tell you about is like we have to assume as a continuous body, and the finite element analysis, or what we say like FAM, it is like you are dividing a continuous body into the small parts, and that's where the analysis compute. That's how you get those plots, contour plots, which we everyone appreciate and understand when we apply some pressures, how we get the reaction forces. So this is it, very introductory video, and in the next video we are gonna see much more deep insight what are the different functionalities. So that's it. I hope you like this, and let me know if anything is very specific to you. I will be more than happy to put it up into the videos. Thank you. Have a nice day.